Okay, so quick tutorial on how to actually measure and calculate the size of any specimen of anything under any microscope. So yesterday we had a table of our magnifications and the diameters of the field of view. So the field of view is that entire circular surface you're seeing under the microscope. But what actually happens is that it changes, what you're actually looking at changes because you're zooming in more and more and more. So that area actually gets smaller. That diameter gets physically smaller in space. The image of what you're seeing is not smaller. It's much like zooming in on Google Earth, okay? So we get a higher resolution. So this is a typical bacteria smear of what are called E. coli cells. They're just prototypical bacterial cells. Now, you'll notice that they're crazy small compared to the paramecium because we are currently at 1,000 times magnification. And at 1,000 times magnification, we're only looking at 180 micrometers. That's 18% of a millimeter in terms of total size. So, what we need to do is take our ruler and measure our diameter of our field of view. Okay, so there's 0 there, and I'm looking at it as 17.8, okay, on my thing. So diameter, field of view of our picture, and that'd be the picture on your phone or a picture that you print out or a picture that's been printed for you. Okay, so you're going to want to measure that. So 17.8 millimeters of my picture. Okay? And we're saying we're dealing with E. coli, so E, length of E. coli, we're just going to go from their length. So I have to find an E. coli cell. Just one cell by itself. Okay. Let's have a look. There we go. That's what I was looking for. Okay. There's some good little guy there. Let's sort of get a parallel angle there. And then on this ruler, it's got almost 4 ticks long. Say 4.5 millimeters. Oh, sorry, that was 17.4 centimeters. So if we convert that to millimeters, that's going to be 178. Okay. Whereas this little guy here, that's this one here, is just 4. So they're really, really tiny. Now we're at 1,000 magnification, 1,000 times. Now that we've got that information, we also know that the diameter of the field of view actually at 1,000x is 180 microns. And again, a micron is if you imagined a meter stick was actually, if you magic school bust yourself down so small that a meter stick was actually a millimeter. Then every millimeter marking on that meter stick is 1 micrometer. Right? So this span here right across is 180 microns total. Okay? We're trying to find out how big that little cell is there. So when we measured it, we got 178 millimeters and 4 millimeters for the cell. Okay, so our diameter. So now what do we do with that? Well, we got to set up what I like to call a magic square. And the way you set up your magic square is you put your target specimen in the top left corner. So on the left side of the magic square is actual. So the length of an actual E. coli cell, or my E. coli cell I should say, and then the actual length, the diameter of field of view, you want to put your 1,000x, whatever magnification you're using. And on this side, that's just your picture. So whatever you're using for your source. Length of E. coli. And I always like to do my little subscript there, pic. Diameter, field of view of my picture. And now it takes just a little bit of math. And it's not hard math, it's just literally a ratio. Okay? So our length of our actual E. coli cell, diameter field of view is 180 micrometers, or microns. That's that weird little UN. 4 millimeters on my ruler. and 178 millimeters for the diameter. Okay? It's good practice to throw these in brackets. You don't have to, but you do have to include units. We cross multiply. What happens here is that, well, we'll write them in. 4 millimeters there. 178 millimeters there. The millimeters cancel each other out, leaving just this unit, which you always want to make sure that you're showing your units in your scientific calculations. This is science, not math. We're just using some math. Can I get someone to do that calculation for me? So 180 times 4 divided by 78. What do we got? 180 times 4 is that divided by 178. Okay, I got 4 microns for that one. So we're going to round off to the nearest micrometer. That is super tiny. Considering that our paramecium yesterday, how big was that coming out? In the hundreds, right? And so that's our final answer. That's how small those are. Now, to get a sense of what you're looking at, each one of those little cells actually looks like this. And so you've got all these complicated features, and even this image here is not as precise as it can be. So every single one of those cells has these components, which is kind of crazy. Right, we're going to go through those components now.